So I'm going to switch to English now, and I'm going to be talking to you about BYOI payloads. So BYOI payloads is a completely new term that I made up for these kind of payloads, and it stands for bring your own interpreter, and it basically allows you to fuse scripting languages with your .NET tradecraft. And we're going to be talking about this in depth. I'm also going to be going through these slides rather fast, and that's just because there's a lot of content to get to very quickly. Okay, and I also have some demos that hopefully will be helpful in order to actually visualize how things work that I'm going to explain. Okay, so quick who am I slide. My name is Marcello. I go by Byte Bleeder on the intertubes. I work for Black Hills Information Security. I'm also the founder of Porchetta Industries, which is a community that tries to support open source software developers. And we can talk about some, if you're interested in that, we can definitely talk about that as well. I'm also the creator of Crack My Exec, Silent Trinity, and a bunch of other open source projects that you can find on my GitHub. The GitHub link is there. And I've spoken at places. I sometimes co-teach for SANS, and I got papers with shiny stuff. That basically sums it up. So for this talk, we're going to be covering really quickly the motivation and background of why I tried doing this in the first place. Some of the key .NET framework concepts, and the reason why we need to talk about the .NET framework is because in order to understand exactly what I'm about to be explaining, we need to all be on the same page in terms of understanding some key .NET framework concepts. I'm then going to be talking about embedding interpreters and engines, which is the main point of this talk. And I'm going to be demoing some example BYOI payloads. And I'm going to be talking about two tools if we have the time, because there is a lot of content here that I developed. Silent Trinity, which is a command and control platform that I made, which attempts to weaponize some of these concepts into a fully fledged C2 framework. And we're going to be talking about Jormungandr, which is another project that sort of tries to weaponize this using Python.NET, and hopefully we'll get to that as well. And then detection, and then questions and answers. So just really quickly, the real motivation behind this is because the death of PowerShell tradecraft. So if you're not from the red teaming community or pen testing community, not familiar with what's been going on lately, the past 6 years ago, I'm probably messing that time frame up, but the past 6 years or so, the pen testing and red teaming community was mainly using PowerShell for basically everything related to testing. Okay, so be it payloads, be it getting initial code execution on a machine, just basically everything in a Windows environment we use PowerShell for. Okay, and some of the now Spectre Ops people created a PowerShell empire, which essentially weaponized a lot of these PowerShell scripts that people were writing and tied it together into a whole nice little framework for us. Okay, and Empire is basically just a C2 platform that throws around PowerShell scripts. So you run a little PowerShell script on the victim machine, and it calls back to your C2, and then downloads more PowerShell scripts, which are tasks. So this is essentially how really quickly how PowerShell Empire works. Okay, so you run a little tiny piece of PowerShell script on a victim endpoint, right? And that little script then calls back to your C2 server, which will be PowerShell Empire. And then PowerShell Empire, when that agent keeps calling back, PowerShell Empire will just throw back a PowerShell script. Okay, and that PowerShell script will be dynamically evaluated on the endpoint, and then the results of that PowerShell script will be sent back to the C2 framework, and that's basically how PowerShell Empire works in a nutshell. Okay, it's really 10,000-foot overview of how that works. Now, in terms of offensive tradecraft, this was pretty amazing because scripting languages, from an offensive standpoint, allow you to be extremely flexible with your tradecraft. Okay, they're dynamically evaluated, which is the main thing about scripting languages, that they're dynamically evaluated, and that brings so much flexibility in terms of tradecraft when it comes to red teaming and pen testing. It's also installed by default, and it allows for completely in-memory execution, which is fantastic. So completely fileless. This sort of ushered in the era of fileless attacks and malware. And it also had access to .NET APIs, okay? And this is a very fundamental thing to understand. The real power in PowerShell comes from accessing those .NET APIs, okay? So it's a .NET language, and we'll talk about that in a second. We'll talk about what that means in a second, okay? Now, years went on, and Microsoft decided to finally do something about this. So starting with, that's actually, I think, actually, I don't recall off the top of my head, but I think starting with PowerShell 4.0, I might have typoed that. I think I might have meant PowerShell 5.0, but I think it was 4.0. Microsoft introduced a bunch of defenses into the PowerShell runtime in order to start combating, or at least getting rid of the low-hanging fruit, or like get it sort of like trying to deny the lowest denominator attacker access to endpoints, right? And they did this by introducing AMSI, which is nothing but a signature-based AV engine inside the PowerShell runtime itself. And the great thing about AMSI, though, is it allows you to signature completely in-memory scripts. Okay, so that's the great thing about AMSI. There's also a script block module and transcription logging. So every PowerShell script that gets executed in the PowerShell runtime gets logged to disk. And then there's also constrained language mode, which is essentially a way of limiting PowerShell's features. Okay, so these are all the defenses that Microsoft introduced. So how did the red team and pen testing community respond? Well, we started patching AMSI. So people started discovering that, hey, we can actually patch this AMSI feature out of the PowerShell runtime dynamically. And this is because of PowerShell being able to access those .NET APIs, okay? So you can just essentially run PowerShell code that patches out AMSI within its runtime, okay? But then you have a problem because Microsoft started introducing signatures of the AMSI patches, so you had to bypass the AMSI patches in order to actually bypass AMSI. It was just a big problem. But there's also obfuscation. We can use obfuscation to get around signature-based detection. That's old school stuff. That's pretty basic stuff, and it can be effective. PowerShell obfuscation can be effective, but it's operationally cumbersome, and it's not exactly something that it fits easily within pen testing and red teaming workflows. There's also PowerShell version 2, and this is I find this everywhere, by the way. I still find PowerShell version 2 everywhere, which is absolutely amazing. PowerShell version 2 doesn't have any of these defenses. So if you find in an environment, if you're doing a pen test and you find that there is PowerShell version 2 installed, you can just run PowerShell version 2 and none of these defenses will be in place, okay? And you can start PowerShell 2 by just passing the -v2 argument to PowerShell and just start up the version 2 runtime, okay? So like if you use PowerShell version 2, you don't have to worry about any of this stuff. And you can revert back to PowerShell tradecraft. But sometimes environments don't have PowerShell 2 installed. So how did the red team community and the pen testing community started addressing this problem? They moved to C#, okay? And the reason why they did that, we'll talk about in a second, but this was the great tooling migration of 2017 and 2019. Everything that was PowerShell then started moving to C#. And the reason for that, there are a number of reasons. If you knew PowerShell, you already sort of knew C#. If you had to do some of the lower level stuff in PowerShell, you had to write C# code. It can do everything that PowerShell can do and even better. And it actually was originally not subjected to any of the defenses in place for PowerShell. And again, we'll talk about this in a few minutes, at least in terms of like why that's the case, e.g. AMSI. And but this has changed as of .NET 4.8. So .NET 4.8 introduced AMSI in the underlying .NET framework as opposed to just the PowerShell runtime. So now you can signature off. So now you can detect malicious C# binaries as well. But again, we'll talk about that in a second, okay? So in response to that, the Spectre Ops team yet again released a C2 framework in order to weaponize in order to make weaponizing C# a lot easier, okay? And this is basically the equivalent of PowerShell Empire in C#. Covenant is essentially the equivalent of PowerShell Empire in C#. And how does it work? It works by executing some sort, either a C# binary or some sort of feature in Windows that can execute C# code, which incredibly enough, there are a lot of those. You get a callback. And instead of and as a difference between PowerShell Empire and Covenant, instead of just throwing down raw source code of a script, it actually has to dynamically compile the C# code on the fly server side and then send down to the endpoint a compiled C# binary. Okay, so this is one of the key differences between Covenant and Empire, and we'll talk about why I find this a little bit weird. Why I find this a little bit not convenient in a second, and this is what led me to this research. And then the C# and then the task just sends back its result. Okay, so this is one of the main differences between PowerShell Empire and Covenant, is that it's not source code anymore. We're now sending down compiled binaries, and we're now compiling stuff, because again, like C# is a compiled language and PowerShell is a scripting language, so you have to compile it in order to do anything in C#. So you're probably wondering, okay, so what's the big deal? Well, I really kind of love the whole PowerShell testing workflow. Okay, so it's not as using C# really just isn't as flexible and easy as a dynamic scripting language, because you have to deal with compilation. And in order to actually do that compilation in the first place, there's a lot of overhead and in terms of code and in terms of setup needed in order to actually get to a point where you can easily weaponize and deploy C# payloads. Okay, and you can do this via a number of ways, but CI/CD pipelines, boilerplate code, etc. Like there's a bunch of things that you can do in order to make this easier, but it's not as simple as just throwing a PowerShell script down to an endpoint, getting that dynamically evaluated on the endpoint itself, and then receiving the task output. Okay, that's the main motivation behind this. So I thought to myself, okay, can we go back to throwing source code around, right? I want to be able to go back to the good old days of using PowerShell. I want to find a way of doing everything that I can do in PowerShell without going through PowerShell, though, because now that PowerShell has all of these defenses, I can't really use PowerShell. But is there a way somehow of doing the same thing I was able to do in PowerShell, only without PowerShell? And I know I'm saying PowerShell a lot, but wait till I get to the .NET section, and then I'm going to be saying .NET a lot. So there really are only two options by default on Windows when it comes to doing something like this. There's JScript and VBScript, and then there's sort of a couple others, but they're not as good as JScript and VBScript, so I'm just going to leave those out. They're provided by default through the Windows script host. However, again, both are also subjected to AMSI, which is a problem, in terms of an attacker. Like, I don't want to deal with any of that. I don't want to obfuscate stuff. I don't want to do anything. So I just want to get around AMSI as much as possible. And you really can't do as much as PowerShell as C# can in JScript or VBScript. Okay, so that's sort of that was sort of a non-starter for me. So that already just made me not want to use JScript and VBScript, because I really couldn't do everything that I could do in PowerShell. Okay. So this is where .NET comes into play, okay? And we're going to be talking a little bit about the .NET language and my approach to solving this problem, which is trying to find the scripting language that allows me to do all of the stuff that I could do in PowerShell, only without PowerShell somehow, right? So this is my humble description of what .NET is. We have to go over some key .NET framework concepts in order to completely grasp what I'm about to talk about. So this is my description of it, because if you go to the Microsoft documentation, it's not exactly clear what .NET is from their documentation, okay? And a lot of people tend to be confused as to what actually .NET is, okay? So my humble description of .NET is, it's a language-independent development platform comprised of a set of tools, infrastructure, and libraries that enables you to create cross-platform applications. Okay. Now, the key phrase of that sentence is a language-independent platform. Okay. .NET is not a language. This is a main misconception that a lot of people have. When people think of .NET, they immediately think of C#. They have good reason of doing that, but C# isn't .NET, and .NET isn't C#. .NET is just a set of tools that allows you to build your own language, programming language, to interact with it. Okay, let that sink in for a second. So we're not. It's just a way of building. Microsoft provides you a way of building your own language in order to interact with .NET tools and infrastructure that allows you to build, that allows you to interact with the Windows operating system. Okay, so it's language independent. So this is where we get into .NET languages, because we talked about it being language independent. That means that there are a bunch of .NET languages. These languages are built to interact with the .NET framework. Some of these are developed and supported officially by Microsoft, and some of them are not. There are third-party languages that other people have built. So there's C#, there's PowerShell, and there's F#. There's also VB script technically and JScript. But these three are the main official .NET languages supported by Microsoft. Okay, you'll notice PowerShell is in there. PowerShell is a .NET language. Okay. C# is a .NET language. F# is a .NET language. On top of that, there are other third-party languages that Microsoft has no involvement in, and the community has built on top of that .NET framework. So there's IronPython. IronPython is nothing more than a Python implementation on top of the .NET framework. Okay, so this is completely different from normal Python. It looks the same, but it's different. Okay, because normal Python is based off of C. IronPython is based on the .NET framework. So two very completely different beasts once you examine the internals of each language. There's also Boolang, which I'm going to be talking about in a second, which is amazing. Boolang is also a Python-inspired .NET language. There's also IronRuby. So these are all third-party languages that can interact with the .NET framework. Okay. Now, before I go any further, one consequence, a very important consequence of all of these languages being implemented on top of the same framework is that they're all interoperable with each other. Okay, so what that means is that what you can do in PowerShell, you can do in IronPython. What you can do in IronRuby, you can do in C#. What you can do in F#, you can do in Boolang, and so on and so forth. Okay, this also means, since they're all based on the same framework, that you can embed them within one another and things will just work, okay? Because the underlying objects and APIs are all the same. And .NET provides you with the ability of embedding languages within one another for specific purposes. So you can totally just take C# and embed that within PowerShell, okay? You can take PowerShell and embed that in C#, and you can take Boolang and embed that in PowerShell, C# within Boolang, and everything will just work. It's just absolutely amazing. The more you go into the .NET framework, the more you realize it's very much a marvel of engineering. It really is amazing. So that's one thing that you have to keep in mind. We also need to talk about what a .NET assembly is, because this is also a crucial thing to understand. So .NET assembly is essentially anything from a .NET language. You take a .NET language, you compile it to something, that's a .NET assembly, okay? So you take C#, for example. Again, this is just an example, right? You can compile PowerShell too, by the way, and you could turn it into a .NET assembly as well, but I'm just making C# an example here. You turn C# code into an executable, that is a C# assembly, okay? You turn C# into a DLL, that's also a C# assembly. From .NET's point of view, in a .exe or a .dll that's been compiled from a .NET language is the same thing. There is no difference from .NET language's point of view, okay? It's also important distinction to make that those that .exe and that DLL that was compiled from a .NET language, in our example with C#, are not the same as native executables and DLLs on Windows. Okay, so the format is completely different. So you take C#, you compile it to a .executable, to a .exe. That is not going to be the same format as a non-managed language executable. So C++, for example. C++ is not a .NET language. If you compile C++, it will not generate a .NET assembly. It'll generate a native executable. And if you analyze the format, it'll be completely different. I'm not going to be talking about what the differences between the format, because that could be a whole different talk of its own. Moving on, there's also a very, very important part of the .NET framework, which is the fact that it's reflective in nature. Which just means is that you can take code and build upon it. You can basically build code with code. And there's a lot of other implications as well. One of the other implications is that there's an amazing function in the .NET framework, which is responsible for most of the C# tradecraft and .NET tradecraft, which is Assembly.Load. Okay, so Assembly.Load is a API within .NET which accepts a byte array. Okay, and you can just give it a byte array of a .NET assembly, and it'll automatically just load that within memory. Okay. Remember when we talked about what's a .NET assembly 2 seconds ago? .NET assembly is any executable generated that's been compiled from a .NET language. What this means is that you can take the bytes of that raw executable, pass it to Assembly.Load, and it'll automatically just load that within memory reflectively without leaving any traces on disks. This is essentially the equivalent of reflective DLL and PE injection built into a language. Okay, so you let that sink in for a second. If you're not familiar with the .NET framework, this might be a little bit hard to completely grasp, but you can think of this as reflective DLL and reflective PE injection built in to a language. Okay, and you can imagine how powerful that is from a development standpoint, but also from an attacker's standpoint. Okay, so what this means essentially is that you can take any one of these languages, compile them, right? You can compile any one of these languages. Let's just get that out of the way. And on top of that, you can take that generated executable or DLL and load it within any one of these other languages as well. So if you took a boolang.executable.exe, you can totally call Assembly.Load in PowerShell and load the boolang executable there. Okay, and you can just keep on doing this over and over again with different other languages. Now, this is the main, that's sort of the main meat behind like what I've been researching, what I'm talking about. And this is exactly what I needed in terms of finding a way to basically access .NET APIs dynamically through a scripting language without going through PowerShell. Because while C# is a compiled language, IronPython, Boo, and Iron Ruby are dynamic languages. They're scripting languages. And they can do whatever PowerShell can do because they're based on the same .NET framework. Okay? So what this means is that you can completely bypass, to an extent, all of the modern defenses that Microsoft has put in place into the PowerShell and .NET runtimes by simply switching to another .NET language. Okay, so instead of running like reflectively injecting Mimikatz through PowerShell, you can reflectively inject Mimikatz through Boo, and almost 100% guaranteed it won't trigger as many alerts as it would with PowerShell. Okay. And again, one of the consequences of being all based on the same .NET framework is that you can embed them within one another. And that's exactly what I'm going to be doing. So again, like all of the defenses originally were in the PowerShell runtime. They were introduced into the .NET framework, but I can just jump to another .NET language in order to bypass some, if not all of those defenses. Okay. So incredibly enough, well, I'm going to be talking about how to actually go about embedding these languages and actually do that. Okay. So incredibly enough, if you've been pen testing or dealing with red teaming or pen test tradecraft in any recent number of years, you've probably done this a number of times without even knowing it. There are a number of projects out there that take C# code and embed it within PowerShell and vice versa. So they take PowerShell embedded in C# for a number of reasons. there's a project called Powerline, which essentially allows you to take C# code, right? And it essentially allows you to embed the PowerShell runtime within C# in order to run PowerShell code without calling PowerShell.exe. Okay, so you can run PowerShell without the actual PowerShell.exe executable because, again, they're all based on the same .NET framework. You can embed these languages within one another, and all of them will just work. So there are a lot of projects that have been doing this already. The only new thing that I've done is used non-default Microsoft .NET languages like Booleang and IronPython, okay? And there's also the reverse, right? You can take C# code embedded in PowerShell, and some of these projects you have to do that in order to do certain low-level things. So one of the first languages I experimented with is IronPython. And IronPython allows you to, it's basically Python based on .NET, right? So it was amazing, but the problem was you cannot call native methods with IronPython because of a number of bugs, okay? So there is a specific part of any .NET language that allows you to essentially call native Win32 APIs, okay? And the reason why we want to do that as pen testers and red teamers is because those low-level Win32 APIs allow you to do all of the good stuff that we want usually, like inject shellcode, interact with like network, RPC, Windows stuff, like all of the good stuff resides in those native RPC calls, okay? .NET provides a way to interact with those native native calls using a specific piece of code, for lack of a better way of explaining it right now. That's called DLL import. So this DLL import attribute allows you to basically interact with unmanaged languages such as C++ or other languages like that, okay? So these are one of the first languages I experimented with. Unfortunately, like it doesn't have that feature. It was broken, but I played with it anyway. It was one of the first ways I started actually learning .NET. And all of the, and I'm going to be doing some demos in a second, but all of the code snippets and all of this stuff that I'm going to be showing you is publicly available. It's at this link that is on the slide right now at the Offensive DLR repo. You can, in that repo, you can find two files, sharpsnake.cs and invoke ironpython.ps1, which embed the IronPython runtime within a C# and PowerShell file, respectively. Another important thing to note, and again, I'm sort of blowing through this because there's a lot to talk about here, is that IronPython requires 4 DLLs that are not present on Windows by default in order to actually spin up its interpreter. But because of .NET and because of that Assembly.Load function, and because you can just basically essentially take these 4 DLLs, embed them within the PowerShell script itself, and then load them at runtime in order to actually start IronPython, okay? So you can completely do this all filelessly without actually needing those 4 DLLs installed on the machine, okay? So I'm going to just skip directly to Booleang because Booleang is the best, okay? So if you haven't heard of Booleang, Booleang is amazing. Everyone should be using it. You know, I guess, yeah, everyone should be using it. Sure, let's go with that. Booleang was originally built for the Unity gaming engine. I found this out only at DEF CON. I had no clue what it was originally for when I started using it. I only found out I was using it for malware. That's the only thing I was using it. However, it was apparently built for the Unity gaming engine. I didn't know that. I found that out at DEF CON a couple of years ago. And it's basically a love child between Python and C#. Okay, and it's very much inspired by Python, but it has some C# stuff thrown in there as well. But the great thing about Booleang is that you can call native functions. So it has this DLL import attribute that allows you to call those low-level functions. And what you see on the screen here is a 16-line Booleang script. Okay, so this is Booleang that allows you to do a memory dump of a process. Okay, so we're basically invoking the mini dump write dump API through Booleang, and allows you to dump in this case LSAS, right? But you can do any process, I guess. But LSAS is by far the most interesting one on Windows. You can essentially dump the memory of a process to disk. Okay, so this in 16 lines, like we've accomplished something that previously we could only do in PowerShell or C#, but with Booleang we're sort of not subjective to all of those defenses that are in place in those two runtimes. Okay. And I'm going to be demoing a few examples with Booleang in a second. So everyone this is a live demo, so everyone start praying to the demo gods right now. But I'm going to be showing you invoke jump scare, which is going to do some shellcode injection with Booleang. It's going to be a Booleang interpreter embedded within a PowerShell script that's going to be executing that shellcode. Okay. But again, like all of these code snippets are available on that repository. So if you want to follow along, and hopefully the font is big enough, but I'll make it very large so everyone can hopefully see. But it's also important to know that Booleang also requires 3 .NET assemblies to run. However, you can, again, take care of that with some .NET magic and Assembly.Load, so it's fine. And I'm gonna do that right now. So here goes nothing. This is gonna be interesting. So I'm gonna stop presenting that window, and then I'm going to present Windows 10. Which hopefully did not update. No, I do not want to update. There you go. See, I knew it. I knew it. I knew it. It was in my bones. Okay, so this is the Booleang shellcode injection script. But before I get to that, let me just pull up the PowerShell script here. Okay, so I'm using PowerShell, but again, it's not advisable to use PowerShell. The only reason why I'm using PowerShell is because I feel like PowerShell is definitely something that everyone is a little bit familiar with as opposed to C#. But again, like you can totally embed Booleang within C#. And there is an example of that on the repository, on the offensive DLR repository that's linked in the slides, okay? But this is an example of embedding Booleang within C#, okay? So this is just a really simple PowerShell script that takes the 3, and you know what? I'm going to make this larger. There you go. Hopefully that's big enough. I made it super big. That takes these are the 3 Booleang DLLs needed to actually spin up the Booleang interpreter, right? This is just some shellcode that I generated from MSF Venom that will pop calc, okay? And that will be passed to the Booleang script, which will be dynamically compiled on the fly and executed. Okay, so this is the load assembly here. We're actually, remember that load assembly function that we talked about? This is actually going to go out and load those 3 DLLs in order for Booleang to start. And we're then just going to call some Booleang compiler APIs in order to actually compile the Booleang script. Okay, and the Booleang script is on disk, but like if you wanted to completely weaponize this, you would make an HTTP request to a remote server and download it remotely. Okay, which is exactly what the original idea of this was. Find a replacement for PowerShell. That's essentially what this was. So again, we're going back to using source code as a way of conducting post-exploitation as opposed to binaries, okay? And this is the Booleang script that we're going to be executing. So this is, again, always on the offensive DLR repo. These are just some DLL imports in order to actually call all of the necessary functions in order to inject shellcode. And I ported over 3 shellcode injection techniques. So there's the inject create remote thread method, the standard classic one. There's wait for single object method. And then there's a little esoteric, but pretty well known by now, queue user APC method. So this is what we're actually going to be executing within the embedded Booleang compiler within the PowerShell script. Okay. So I am now going to run this. So I got my invoke jump scare. Oh no, it helps if I spell. Let's try that. Yeah, invoke. Oh my God, 1 second. It is. I just want to point out it is 4:30 in the morning here, so like my brain's still waking up. I apologize. Jump scare. Perfect. Boo. Okay, and we have calc. Okay, so what this did, again, just to recap, we've essentially found a way of dynamically executing code without using PowerShell. So it's a completely different language, and it sort of removes the need of obfuscating PowerShell scripts, because you can now just write all of your post-exploitation in Boolang and embed that within any .NET language in order to actually conduct post-exploitation, okay? And again, to fully weaponize this, like this is a really dumb way of doing things, but to fully weaponize this, you would grab this Boolang script from a remote server, right? And via HTTP or whatever C2 COM you prefer, and actually execute this dynamically, which is exactly what Silent Trinity does, which is the project that I made in order to actually tie these things all together, okay? Just one more thing before I go on. That was a really complicated, that was sort of it wasn't exactly probably the best way of introducing this concept to you. So because of that, I did write another Boolang PowerShell script that's a little bit easier to understand. This is so, and this really hopefully gives you an idea of sort of the power that this gives you. What this does is it actually dynamically compiles. So this is Boolang source code. Within the PowerShell script, there's Boo source, right? So this is Boolang source code within the PowerShell script that'll get dynamically compiled and executed when I run this, right? So if I do this, invoke Boolang. So hello from Boolang. Okay, so this is the output right here of this. So we've basically found a way of dynamically executing code that allows you to do everything that PowerShell does, only without using PowerShell, okay? And on top of that, you can embed this within other .NET languages such as C#, which allows you to add scripting capabilities to your implants and malware, okay? Hopefully that makes sense. And before I continue, let me stop presenting and then go back to the slides. I want to see my PowerPoint. Yes, please. Okay, so it should be back to the PowerPoint slide now, okay? So that was just Boolang. But once I started going down this rabbit hole, I found a bunch of other .NET languages that I could use, such as ClearScript, okay? ClearScript is amazing. It is a officially supported Microsoft project, which is also something fantastic. And it basically was designed to do exactly what I want. It allows you to add scripting capabilities to your .NET applications. That's exactly what I want. It supports JScript and VBScript out of the box, okay? Now, this doesn't, I originally thought this had its own JScript implementation, okay? It does not. It uses the built-in JScript implementation and VBScript implementation of the Windows script host environment on Windows, okay? So what this means is that any code that you run, any JScript or VBScript code that you run through this ClearScript engine is subjected to AMSI, okay? However, there is an incredible thing that ClearScript allows you to do. Remember before when I mentioned that JScript and VBScript natively can't do everything that PowerShell does because it can't really access a lot of the .NET APIs that gives the power of PowerShell, where ClearScript allows you to basically give more power to JScript and VBScript by exposing .NET APIs to those two languages, okay? So this right here on the screen is a, I'm gonna like 30 line, yeah, probably 20 line C# code that embeds the ClearScript engine and dynamically executes JScript within ClearScript, right? However, if you're familiar with C#, you'll see some funky stuff going on here, because you'll notice that I am calling .NET APIs from JScript now, okay? So ClearScript allows you to expose the underlying .NET engine to JScript and VBScript and actually dynamically call those .NET APIs. Okay, so what this means is that now we can actually use JScript and VBScript through ClearScript embedded in C# or whatever other language to do post exploitation. Okay, and I'm going to be doing a demo of that. And one other thing that I would like to mention here, I did say before that this is subjected to AMSI, but because ClearScript allows you to expose the .NET engine to JScript, you can actually now patch AMSI out using JScript and VBScript. So now we're back to the whole PowerShell situation where we're playing the chicken and the egg problem. But because of ClearScript, you can now inject shellcode. You can now do all of this crazy, all of the great and crazy stuff that we do as pen testers and red teamers through JScript and VBScript, okay, which is incredible and allows you to do a lot of great stuff with other existing tooling like Kodiak. If you're familiar with Kodiak, I think I pronounced that wrong every single time, but there's a JScript C2 platform called Kodiak. One of its limitations is it can't do this yet. It can't call .NET. It can't call native APIs, but with ClearScript, you can completely do that with Kodiak. So that's another thing to keep in mind. I'm going to be quickly demoing you invoke ClearScript now. Let me present the right screen. So I'm going to stop presenting in a window. Yes. And I'm going to go to Windows 10. Is it doing it? It's thinking about it. Yeah, there you go. Okay. So you hopefully should see my Windows 10 VM now. Let's go back to that folder. And again, this is all on that offensive DLL repository, so that's fine. You can get this code from there. But again, what I'm going to be doing here is showing you a PowerShell script, which embeds ClearScript within PowerShell and is going to be basically executing .NET APIs. Okay, so here we have if the code patterns are all the same. You have a DLL which you have to load with Assembly.Load. You then get access to the code within that DLL, which in this case is the ClearScript engine, and you can now access all the functionality through PowerShell or any .NET language you prefer. So here, what I'm going to be doing is just calling the system.console.writeLine, which is going to write to the screen, which is going to just write to the terminal. And I'm also going to be executing a command, a operating system command through the WScript shell ActiveEps object. This is just to demonstrate that now you can access both JScript APIs, native JScript APIs, and .NET APIs, because without ClearScript, you wouldn't be able to access the system.console.writeLine function, okay? So I'm going to load this in. And there you go. So again, hopefully I'm conveying. Hopefully I'm explaining this in a way where you start to understand sort of the power that lies in something like this, because you can now do everything dynamically as opposed to using executables and go back to the way we used to operate with PowerShell. Okay, to an extent. And there's so much to talk about here. Some of the stuff, some of how this works, I still don't completely understand. But again, hopefully I'm explaining this well. Let's go back to my slides here real quick. And how much time? I think I'm running out. I think I'm almost there. But let's go back to my slides. And yeah, someone is gonna have to stop me. Giovanni, you're gonna have to stop me if I go because I'm just gonna keep going. Okay, so .NET Alchemy Recipes. So again, like the more I went through this rabbit hole, the more I found, the more languages I found. So these are all of the .NET languages that I've found so far. Okay, so what this means is, so with these, you can take these languages and embed them within your malware to add scripting capabilities. So if you wanted to embed Lua within your malware, you can totally do that. There is a project for that. There's JavaScript. There's a JavaScript implementation. There is a WebAssembly implementation, which if I ever get some time to play around with, I am totally playing around with that, because it would be kind of freaking amazing to dynamically embed and execute WebAssemblies within C# for malware. That would be kind of crazy. There's ClearScript. There's IronPython 2. There's IronPython 3, which is in the works. And there's also Iron Ruby and Boolang, obviously. But out of all of these, by far, the most feature complete one that I found so far is Boolang. And that's what I wrote Silent Trinity in, which I don't think I'll have time to demo, unfortunately. But that's that. If I had to recommend one language to play around with, it would be Boolang, because it's the most feature complete and the documentation is pretty good. So bonus round. So as I said before, like .NET is a set of tools that allows you to build your own language. Some of these tools also allow you to build your own compiler for that language really, really easily. Incredible, right? So Boolang, for example, again, is a perfect example. Is because it comes with its own compiler. Okay, so say you're like, Marcello, I don't want to deal with any of this embedding stuff because it's too complicated. I don't want to deal with it. That's fine. You can totally take those Boolang scripts that I just showed you, compile them to a .executable, and run them on Windows. Like, you can totally do that too. So you can easily weaponize this stuff without having to do the embedding. Although the embedding is sort of what adds that extra layer of flexibility, right? But again, like that executable that generates, that you get from compiling Boolang, is also .NET Assembly. So what that means is that you can take that compiled Boolang executable and run it within PowerShell or C# or whatever .NET language you want, because that's just how .NET works. It's amazing. Taking advantage of existing tooling. So this is the main problem. So say, I convince everybody that maybe C# isn't the solution to this. Maybe we should start looking into these third-party scripting languages to maximize return on investment on red team operations. The problem is we've gone too far. Like we've gone too far down the C# rabbit hole. So most of the tooling out there has been ported over to C#. So in order to completely operationalize this, you have to port over the C# tools to Boolang, right? Incredibly enough, there is a project called Sharp Develop 4.4 that has a C# to Boolang translator. I don't know. But it does have it. So you can literally copy paste C# code into Sharp Develop 4.4, which is not the latest version. It was removed in the latest version. That translator was removed in the latest version. So you have to get exactly version 4.4. And you can totally just copy and paste C# code into Sharp Develop, and it'll spit out Boolang code. So you don't even have to worry about porting over tooling anymore. You can just use Sharp Develop. It does take some, like, it's not completely 100% foolproof. Like, you are going to have to fix some things up, but it's a hell of a time saver if you do go down this route. And I have 5 minutes left, so I'm just going to skip over that because I want to get to a few things. So Silent Trinity is the tool that I wrote to weaponize these concepts that I've talked about, and it uses Boolang. It originally used IronPython, but I switched over to Boolang. So definitely check that out. Another tool that I wrote was Jormungandr, but this uses Python 4.NET. Python 4.NET is different. Basically it's not a .NET language. It's standard Python, but it interfaces with .NET in order to actually call those .NET APIs. So with standard Python installed, you can actually do whatever PowerShell could do. Okay, using Python 4.NET. And you can totally pip install Python.NET. If you find Python installed by default on a Windows machine, you can totally pip install Python for .NET, and now you can do whatever PowerShell does because you can interface with the .NET framework, okay? And you can also embed standard C Python, right, within C# using Python for .NET. And there's an actual paragraph saying, because the Python code running under the Python for .NET is inherently unverifiable, it runs totally under the radar security infrastructure, so you should restrict use of Python, which is exactly what I want. Okay, and I wrote a tool called Jormungandr. I haven't released this publicly yet. I still have to clean it up, but it's basically like you can think of it as sort of like a mini Python installer in C#. But the end result is you can basically call .NET APIs from regular Python, which also allows you to basically install like Impacket and all the other stuff because it's regular Python now. We're not dealing with Iron Python, which is not built on C Python. This is regular Python. So hopefully I'll get that sorted out soon. Detection, really quickly. Remove PowerShell. If you have anything less than PowerShell version 5, remove it everywhere, okay? Just get rid of it because these are general .NET tradecraft detection recommendations. Like this is not specifically tied to the research that I presented, but generally, like for any sort of .NET tradecraft, remove PowerShell less than 5.0 everywhere, okay? Which in some organizations, that's pretty easy to do, actually. I would also recommend removing .NET less than 4.8 everywhere, but that's actually somewhat pretty hard to do. So that's definitely going to be something that you to think about a lot. But that's because, and the reason why I recommend this is because those versions less than 5.0 and 4.8 don't have AMSI and any of those detections in place that Microsoft put in, okay? I would highly recommend sticking with Microsoft products as possible when it comes to EDRs. Highly recommend it. And the reason why is most third-party EDR solutions, incredibly enough, still don't integrate with AMSI. So what this means is that if you decide to use a third-party EDR, silence, or any of those, right? If you use silence, turn off Defender, you will not see detections for AMSI. Like silence, from at least last time I checked, I guess I said it out loud now without coughing, but last time I checked, does not integrate with AMSI. So again, I would just highly recommend just sticking with Microsoft products as much as possible because any third-party stuff is a gamble. It really is. Lee Holmes, on his Twitter, he also has a up-to-date spreadsheet of all of modern EDR solutions and AV vendors that actually do integrate with AMSI. This is, I think, somewhat the latest one. Unfortunately, it's very unclear trying to get in contact with these vendors, trying to actually understand if they do integrate with AMSI. I'd highly recommend, if you're trying to look for a new EDR, get AMSI integration. Press them, say, if you do not have AMSI integration, I do not want your product, because if you're not looking at AMSI logs, you're doing it wrong. You're absolutely doing it wrong. There's also this new technology called ETW, which is, you can think of it as telemetry. These are some links associated with that, but really quickly, ETW allows you to see stuff like this. So it allows you to see .NET assemblies loaded within memory, okay? And this is extremely important because you can see, like, hey, this process has Booleang loaded. That's probably evil. That's probably bad, right? I've heard of Booleang before. Someone does really bad things with it. You should probably take a look at that, okay? So ETW allows you to introspect into the .NET runtime and actually, like, get any sort of information from it. It's basically the only thing that allows you to do that right now, at least from my knowledge. So definitely look into using ETW to supplement your detections when it comes to .NET Tradecraft and this. And finally, that's it. If there are any questions, let me know in the chat.